All right, so now that we have defined what momentum is, we're going to see if we can find a way to use it to say something interesting about physics. And the way that I'm going to start is actually going to a different previous expression that you're probably familiar with, which is Newton's second law, or the law of motion, which says that the net force acting on some system should be equal to the mass of that system times its acceleration. Which if I want, I could rewrite using the definition of acceleration to look something like this. And once I have that, I recognize here that if I could get rid of time in this expression, I have something that looks very momentum-like. So what I'm going to do is multiply both sides of this expression by time, giving me something that looks like this. And then I'm going to integrate both sides with respect to time, from some initial to some final time, like so. On this side, when I do that, if I'm able to assume that the mass of my system is constant, then what I can do is write this as the mass times the integral of dv, which is simply the velocity evaluated at these endpoints, which would be the change in velocity. Another way of writing that would be mv final minus mv initial, or even if I wanted to use my new quantity of momentum, I could write this as p final minus p initial, or even delta p. So now I see that if I can say something about the change in momentum of a system, I can set it equal to whatever this quantity over here is. And so we're going to give this quantity a new name. We're going to call it the impulse. And in particular, we're going to think about net impulse, which we'll use capital J for impulse. Net impulse as being defined as the integral from some initial to some final time of the net force acting on my system with respect to time. And now putting this equation, or this definition rather, against this result from our integration, we can write something called the Impulse-Momentum Theorem, which works exactly analogously to the work-energy theorem to give us a new possibility for thinking about when something is or is not conserved. We've thought about whether energy is conserved or not. Now we have a way of talking about whether or not the momentum for a system is conserved.